In this particular lesson, we'll talk about the chip configuration of microcontrollers. So we start with the packaging. The microcontrollers, they come in different packaging: DIL, dual inline packaging; SOIC, small outline IC, it's an 18 pin; then quad flat package, 32 pin; and ball grid array, 100 pin. So these are the four packaging in which the microcontrollers come. We'll talk about them one by one. Now this is an example of dual inline packaging. There are 8 pins, 4 on one side, 4 on the other, and the numbering starts from the dot on the top. SOIC, small outline IC, it's an 18 pin package. As you can see that the particular IC is PIC 16F1827. QFP quad flat package. There are 32 pins, 8 on each side, and the pins are on all 4 sides. These are basically SMDs. SMD stands for surface mounted devices. And ball grid array, larger microcontrollers, they come in this kind of packaging. There's little balls at the on the lower side of the chip. These are the connections. Now PICX is a very small microcontroller. It's an 8-pin microcontroller, and it has only 8 pins, as you can see. You would be interested in PIC and Arduino at Mega microcontroller. So this is the PIC 16F. 16 stands for 16-bit. As in my previous lesson, I mentioned that these are the bus size. So this also comes in dual inline package, quad package. Number of pins is 44. So we'll talk about their different pin assignments. There are ports which are denoted by A, B, C, D. RB7 to RB0. These are the 8 pins of port B. As you can see, the port B, port C, port A. So there are A, B, C, 3 ports. Each has different pins. Port D and port E, they are also used for slightly different purposes. Port E is analog. These are the different pin assignments. Pin number 1, 2, 3, 4 till 20 on one side, and from 21 to 40 on the other side. You need to note the sequence. It starts from the left side once we are ring from the top, and the pin numbers go down increasingly. Then Move on to the right side, and the pin numbers go from bottom to up. The peripherals of PIC 16F887, they are GPIO ports A, B, C, D, E, then there are EPROMs, communication protocols, then there are timers, external interrupt, PWM, and analog to digital converter 10-bit. It has a 10-bit analog to digital converter. If the requirement of the project is that the ADC should be 10-bit, then you can use this. But if the requirement of the project is that you need only 3-bit ADC, then you might as well use a cheaper microcontroller. Now this PIC 16F18877, it has a 32 megahertz internal oscillator, 10-bit A to D converter, 5-bit digital to analog converter, two 10-bit pulse width modulators. These are the key attributes of the PIC microcontroller. And its communication protocol are SPI and I2C and EUSART. This particular microcontroller is available in 40 and 44 pins. Now coming on to the Arduino. Arduino is using Atmega 328P. It's a 28 pin chip. It has 14 digital I/O pins, of which 6 can be used as PWM outputs, 6 analog inputs, 16 MHz ceramic resonator, USB connection, power jack, and in-circuit programmer, serial programmer. In-circuit serial programmer, the function is that while the program is running, you can change the program. Over here you can see that the pins, they start from the left side, 1, 2, 3, up to 14, and then from bottom up, 15 to 28. This is a 28 pin Atmega 328P. This is used in the Arduino boards. It has 6 analog inputs. You can see port C, pin number 23, that's analog input 0, and pin number 28, that is analog input 5. And port P is all digital. Similarly, port C is also digital. I/O ports, and port D is also digital pins. At the same time, they can be used as PWM. Pin number 2 and pin number 3, they are receive and transmit pins. You would be using them once you are receiving data in serial ports or transmitting data to serial port. The ports are analog and the ports are digital. Then there are input ports and there are output ports. And some ports are I/O ports, which can be used as input as well as output. For an analog port, only analog signal can be transmitted or received. For a digital port, only digital signals can be transmitted or received. Input is only input port and output is only output port. And I/O ports are the ports which can be used for input as well as output. This is the pin assignment. D0 is port D, pin 0. Pin number is 1. D1 is pin number 2, D2, D3, D4, D5, D6, and D7. So there are 8 pins in one port. Then these are D stands for digital, not here. Uh, D stands for digital. So these are the digital ports. And these are the 14 digital ports up to pin number 14. And then 18 and 19. These are the digital I/O ports, pin number 17 and 18. They are digital 18 and digital 19. Now, pin number 19 is not connected. Pin number 21 can be used for resetting the chip, and active low means that you got to connect it to the ground. It can work on 3-volt power supply, 5-volt power supply as well. Pin number 24 and 25 are ground. Pin number 27 till 32, these are the analog input ports. That's all for these two particular microcontroller chips. We'll continue the lesson. And in the next lesson, we'll talk further about the